Hey folks, Sebastian from Madrigal here. Welcome to part 10 of the video series where we create a Vulkan renderer for the Basis game engine. If you haven't watched the previous parts, make sure to do that before you continue, or otherwise this might not make sense. So we're indeed at part 10 and we're not quite done yet, so a few parts ago I estimated that this would be a 10-part video series, but seems like we're gonna go a little longer than that. But that's not a problem. We're nearing the end and we're actually fairly close to be able to render anything. And I think actually when we will be able to render something, we will almost be able to render everything we set out to do. Implementing a backend like this is sort of like a all or nothing deal. When you are wrapping it in a custom GFX API, behind a custom GFX API like this, you kind of have to implement the whole thing, and then when you do, everything is just kind of falling into place. But I'm sure that we'll have some graphical corruption bugs like that we'll have to figure out. So, we have essentially two large pieces left to do. We have the render context, which is like sort of like the entry point to the render pipeline, in the sense that this is, for example, where we actually draw our primitives, or draw anything really, and it's also where we bind our resources. More binding. We have the render pass handling here, and indeed we present things to the screen. So this is one thing that we still haven't implemented. This is completely empty. But I think we'll do this last, because before we go that far, we have one more piece to actually put together, and it is the pipeline state. And the pipeline state is kind of annoying at the moment. We're using the VEC Vulkan helper library, and I'm going to try to draw why I feel it is a little annoying at the moment. So, when we want to draw something, let's say we have a D3D11 renderer like this. We have a draw call, which sits here in the middle like this. We have a draw call, and before we render, before we call this draw call, we have to set up some state. And so, in D3D11 we have all these individual boxes of state that we have to set. So we have like the rasterizer, for example, and we have the blend state, and we have the like the depth testing. Depth testing state, and all kinds of other things that we set up like this. And these are all sort of individually bound to the system, and then when we issue the draw call, then we get something out. And whatever you have set the state to will affect how this draw call will actually carry out the work. So then you have the modern APIs, something like Vulkan. And in Vulkan, you don't actually work like this. Indeed, you have all these individual boxes again, and they contain essentially the same state as with D3D11. But you create something called a pipeline state. I think that was what it was called. I don't remember exactly. If you look online, you see the term PSO, which stands for pipeline state object. And you essentially create these up front. So you have the whole thing sort of packaged in one of these guys. Shaders, by the way, also are referenced by this PSO. So then when we do a draw, we can simply bind this guy. So this is just binding. and it binds essentially this whole PSO in one go. And this makes it pretty efficient on the runtime side, because you can just bind the same PSO all in one go, and all of this state is already contained inside this PSO. So the Vulkan runtime doesn't have to sort of track all these individual boxes like this, like it does in the D3D11 backend. Okay, so in preparation for the new backends, even though my main rendering backend currently is D3D11, what I actually do is I have like a GFX API PSO, which I fill in with all the state that needs to go into it, like this. And then this is bound. So bind to the pipeline, like this, and then you can issue your draw calls like this, right? And so on. And this is of course not really the way it works with D3D11. So when you actually bind this thing with D3D11, it actually goes in and individually binds each one of these guys to the pipeline separately, because that is how it works in D3D11. However, the API is built like this so that I can very easily actually prepackage everything into one of these GFX API PSOs and just bind it to the pipeline. Okay, so what makes this thing a little stupid is that what we're going to have to actually do now is in our pipeline. So let's just call this PSO again. Again, we have all this state, and we need to put into the PSO object, and the PSO object will create a VEZ state, pipeline state. VEZ, let's actually just take that out and do like a VEZ PSO, right? But the thing that they've tried to actually make it, easier to work with the VEZ PSO, in the sense that VEZ PSO doesn't actually contain almost any state at all, and you're still able to individually set all of these things when you do the drawing. So VEZ will actually sort of split it up into individual boxes again, like this. And then, because we have Vulkan sitting underneath VEZ, right? VEZ is just a thin layer of Vulkan. We then need to, once again, and at runtime, put it in, create like a proper native PSO with all of these things contained, and then Vulkan can issue its draw calls like this. And here we have the binding to the actual pipeline again. So this is kind of silly, because we're essentially we have collected them already, and we hand them to VEZ. VEZ wants us to split them up into individual pieces just to put them back together again in native Vulkan so that we can bind them. So this is one area where I actually think I will, not in this video series, but later on, I will actually have to just modify VEZ a little bit, so that since I have all of this data already sort of collected into this one thing, we might as well just go directly from this to the one Vulkan PSO. Skip this whole part completely, which should make the runtime part much more efficient, because it no longer has to track these individual things and create sort of essentially dynamic PSOs at runtime. I hope this makes sense. It's kind of one of these things that I sort of wished VEZ didn't actually abstract away. But like I mentioned in the previous part, the VEZ code is actually not super complicated, so I think I should be actually able to make that change. Okay, so like we've done with previous things we ported over to Vulkan, let's have a look at the metal version of this guy. So, oh, that's the VK one. That's the one that we're going to fill in. This is the metal one. So, a pipeline state contains a lot of state, hence the name pipeline state. But we can see here that it stores things like the primitive type, the binding, clockwise or counterclockwise, the fill mode, the cull mode, depth bias, slope scale, blah blah blah, all these kinds of things. And it has a something called a get pipeline state for render target function, which when we actually look at what it looks like, it's right here. We actually we create these sort of on the fly. So when you want to render into a render target, you pass the render target metal pointer here, and this guy goes and figures out, do we actually have one cached already, and then it returns one if it finds it. If it doesn't find it, then it goes and creates one dynamically. And here is where we actually turn a lot of the GFX API basis things into native metal equivalents. And with this descriptor here called RPD, we pass it into new render pipeline state with descriptor, get this kind of metal render pipeline state back, and we return it, essentially. So that is it, and once we have returned it, then we push it to the list, to the hash map of states, so we don't have to recreate it all the time. And then if we look at the render context in metal, so render context metal, we have bind pipeline state here, and on the, not that, but the source, on the implementation side, you can see here that this is essentially binding the state to the pipeline. We have this kind of render command encoder. This is sort of like, this is what will actually be, I think, a command buffer on Vulkan, if I remember the terminology correct. And this is essentially binding the pipeline state to the render command encoder, sorry. And you can see that in metal, we don't actually, not everything gets set by binding this thing. We have some things that we need to specify separately. So we have this depth stencil state, the binding, the cull mode, stencil references, depth bias, and depth clip mode. These are things that I think in native Vulkan they're actually part of this PSO, and I think that's the case in D3D12 as well. But this is more like the D3D11 style, where you bind a pipeline state, but you still have to set some individual things separately. And if we go to D3D11 and see how it works there, we'll see that everything is set separately. And yes, we actually happen to be in that bind pipeline state. We get it in, we cast it to the correct type, and then we actually go in and I have these checks here to see if we actually if we have already set the correct state previously. But if we don't, then we have all these D3D context setters here to set all the shaders separately, set the blend state, depth stencil state, that's the rasterizer state. All of these things need to be set. And so in the modern pipelines, this would all be just one thing. One thing setting everything up, including the primitive topology, I think. So that is what I would like to actually happen in my new Vulkan backend as well, but I don't think that will happen in this video series. We'll have to set the state separately, because that is what VEZ unfortunately expects of us. So we can have one last thing here before we actually start coding anything. We create a graphics pipeline, and as you can see, essentially the only thing you have to give it here is the shader stages, or are the shader stages, and you get a VEZ pipeline out. So you actually you feed it very little data here, but GFX API, expecting us to use modern APIs now or in the future, actually bundles everything together. So we have a lot more information available than what VEZ wants us to hand to it. Okay, I'm gonna drag this off to the side so that I can consult this when we actually start filling in the data that we're going to bind. All right, so I'm just gonna have a sip of coffee. Always have a sip of coffee before you do anything new and important. That is my advice. So we'll start, as we always do, by setting up the device pointer here, device VK. The shader program is going to be very important here. As we looked at in the VEZ documentation, that is actually the only thing we currently need to give to the VEZ pipeline. So let's hold on to that, and we actually get it here already. Apparently in the metal one we had like a metal one here, and now I just renamed everything, so we already get like the shader program VK in. And as we saw in the documentation, what we will actually be binding to the pipeline from the VEZ perspective is something called a VEZ pipeline. So we'll VEZ pipeline. We'll keep one of those guys at hand as well. And let's maybe move this here and drag this here. I think I'm used to working the other way around. I'm set in my ways like that. So we have the header here, we have the implementation here. We will initialize that guy, and we will initialize this guy, and we will initialize this guy. Not ready. No, null handle. There we go. And here is, of course, the init method, and I think we should actually have this called for us already. Let's try to run this and see what happens. Yes, we want to use Vulkan. Thank you very much. And here we go. And what is going on? What is going on? We need to step one step further to get some sensible things out of the debugger. And what we are getting here is a fairly typical shader with two stages. We have the VEZ vertex input format, which we created earlier. We interestingly don't have a description. What? Oh, yeah, right. Okay, we actually don't yet. We don't actually have a description here. They don't hold on to their description pointers. Yes, I remember that now. It's unnamed, annoyingly, but we can actually have a look here and see what is being fed to us. So, material description. Yeah, it doesn't really tell us anything. You can see here. Okay, so we're creating a material for the mesh shadow map material. Right. And when you create a material, we go into the renderer, create material. This is obviously, some materials aren't really anything that we have to deal with. They're like a higher level renderer construct. But when we create a material, sooner or later we're going to create the PSO. So here is how we create a PSO on GFX API. We have the render pass descript description, which has a PSO description, and this has all kinds of things set for it. Depth stencil state, rasterizer state, blend state. We have the shader program, which has all kinds of stages and whatnot. It has the vertex format, etc., etc. And then you call create pipeline state, passing it the PSO description. Right. Okay. So here is where we can start creating our actual pipeline, and also setting up or sort of getting a hold of and initializing the state, everything that we need to actually do when we bind this thing. So let's maybe create a, because we have so many things to bind here, we have to do it by hand because VEZ is set up the way it is. Let's create a bind function for us. And just like the metal one, let's accept a render target. Render target. I suspect we will need that later on. And then we can have a look at the documentation again. And we have to essentially figure out all the state. Where was the pipeline state? I think it was somewhere here. Graphics state. Right, so here we go. As described in pipelines, VEC removes all the graphics state specification from pipeline creation. In VEC, graphics state is set dynamically while recording command buffer. Yeah, this is the thing, that's not the case in native Vulkan. All available dynamic states from Vulkan are enabled by default, and their corresponding command buffer functions made available in VEC. States aren't required to be set when render passes, blah blah blah. Okay, so we have like all of these states need to be set. And that one as well. So let's just bring that to the side. Let's just bring that to the side, and we'll actually initialize a member of each of those types here. We have input assembly state. Oh, come on. Jesus. Right, so input assembly state. Then we have a VEZ tessellation state. The tessellation state is actually it's something that was introduced into VEZ through one of those pull requests that I merged, and now it can't find it, and I wonder why. Where's the tessellation stage? Tessellation state is right there. Why are you complaining to me? Why are you complaining? Tessellate. Oh, it's with two L's. All right. All right. All right. And then we have the VEZ rasterizer state. That's the one. This IntelliSense is not making it particularly easy to get these things right. I'll just copy paste them from here. So we have multi-sample state. Come on. And we have depth stencil state. And we have color blend state. And then finally we have color blend attachment state, and that is actually going to be an array of 8, because we have 8 possible blend attachments, just like we do with other graphics backends. All right. Let's see if I got them all. Input assembly, tessellation, rasterizer, multisample, depth, color, and color blend. Right. And then we have a bunch of, let's see if we go here, we should go to VEZ.h, and we can just temporarily drag it there. So we have these these commands to set things. Like here. Let's actually just copy all of this over and comment it out sort of like this, because here we can see actually what we want. So what do we have? We have the vertex input format that comes from the shader. We created it earlier in an earlier part. Viewport state, viewport count. Okay, interesting. Oh, there's a set viewport and viewport state, which is just the count. That's confusing. But no. Okay, so input assembly state, we have that already. Raster process state, we have that as well. Multi-assembly state, we have that. Depth stencil, we have. Color blend, we have. Tessellation. So we have all of those essentially. The viewport will be set through a separate command. We're not actually going to hook that into the pipeline. Same with the scissor. Then we have line width. Okay, then that's a float, so we will have to probably call that as part of setting this thing. We have depth bias. That's 3 floats, so let's get a hold of those guys. I'll just quickly add an M there to mark them as members, because that's how I like to roll. So those guys. Blend constants, okay. 4 of them. All right. M blend constants. Min depth bounds, max depth bounds. I don't know exactly what those are, but let's add them here anyway. And depth stencil compare mask, right mask and reference. I think we have these like specified a little differently on in the GFX API. Yeah, so here we have an enum for the front and back. And confusingly, we have 2 with almost the same name. Okay, and GFX API has these specified a little differently. Pipeline state. And we go here and we can see that we have here like a front face, and it has all of these things, and then a back face. And again, it has all of these things, but it has stencil fail, depth fail, pass op, stencil func. It's essentially like the same thing that we have. Compare right and reference. Yeah. Okay. Right, so actually it's just the masks. So it's a read mask, the write mask, and the reference. Okay. I call it the read mask, they call it the compare mask. And they're unsigned int 32s, all of them. Like this. So what we can do is create a bunch of unsigned int 32s, and we can call them like stencil front read mask. Oh. And it will be right mask, and then we have reference like so, and then we have the same thing for the back side like so. Okay, I think that should be it. I think that is actually what we need to do here. What we need to sort of store. And when we have all of this, and we have all of this filled in, and we also have this guy properly created and initialized, we can do all of that in here. Then when we bind, when we call this bind, we can actually just set all of this in one go, and that should be essentially the best thing we can do right now at this point. Right. To be able to call those, we actually need to probably pass in some kind of command buffer here, right? Let's have one last look. Let me just uncomment that and get one of these guys, like blend constants, for example, and then go to VEC, and we go here. Yeah, like interestingly, they don't actually take the command buffer. Oh, I remember actually, yeah, I remember. Let's see. I remember reading something about it tracking the let's see. Right, so, okay. All VEC command functions are associated with the VK command buffer passed to VC begin command buffer within the same application thread, right? So we don't actually need to pass that. It kind of keeps track of that within the thread. And we do need to actually have called this begin command buffer to be able to call these guys at all. So yeah, we don't need to pass anything. I think the render target will be enough. Okay, so let's take another sip of coffee and get to work. So, we'll probably want to initialize at least some of these guys to something sensible. I'm gonna do line with. Actually, I'm gonna be lazy now. I'm not actually gonna be able to. I'm not actually going to initialize all of these anyway, so they're going to be set in the init function anyway. Let's be bad citizens and not do that right now. Okay, so the first thing we'll want to do is just hold on to this shader program, and we do that, of course, by adding a reference to it, like we've done previously. They are GFX objects, and GFX objects are reference counted. And because we do that, we will actually want to release the reference here and call, or actually just set it back to null pointer. And I'm gonna go ahead and guess that there is like a destroy pipeline. And there is. Get device. Get VK device, and this would then be the VEC pipeline, and we can set VEC pipeline to VK null handle. So just like I've done in previous parts, you can sort of, if there is a create VEC something, VEC create something, there's typically a VEC destroy something. Okay. And yeah, maybe should we do the creation first or the binding? Maybe the creation. Creation is the more complex one. Let's just get it out of the way. So looking at the docs here on my other screen, we need to fill in like a VEC pipeline creation thingy. Create info? No. I said create info. No. Pipeline. Oh, right. Actually, yes. So we need a shader stages, which will be as many as our GFX API supports. And if we look at this guy, this had some way of actually returning. Yeah, we commented out that do not have to do getters. We have shader modules, some of these shader modules can be VK null handle, so we'll want to skip those. I'll just drag that off to the side as well. So what we can do is we will do stage count, and then for uint I is 0, I is smaller than, probably need to cast this because it's an enum, so that would be gfx API shader type count plus plus I, like so. Oh, not that. If m shader program m shader modules I is not VK null handle, so if this shader stage is active, so to speak, we take this guy and we call stage count. We can use that as the index. So we initialize it and then we set the module, I think. The stage count again dot yeah, I don't think we should need the entry point, actually. Let's just start by doing module, and we can do essentially like this. And we can do that. Right? So we're filling in, like this is an array with holes in it. If you have VK null handles, this will be an array without holes, and with this number set to how many we actually use. That's cool. And then we have VEZ graphics pipeline create info. Create info. Initialize that as well. And what does it want? So it just wants the stages and the stage count. So that's that's shader stages. And stage count is stage count, quite simply. And with this we should be able to create the actual VEZ create graphics pipeline, like so. We'll feed it the device, get VK device, give it the address of create info, and give it the address of MVEC pipeline. Basis assert that result is not, or actually that result is VK success, and we do the same thing we do in other places, where we actually write that this guy failed, and the result is that, not that, but that. Okay, so let's try that and see what happens. Okay, what do we have? Stage count 2, that looks quite good. Success, yay, hey. This is almost too easy. I'm afraid that the ball will drop at some point and we'll have some catastrophic graphics corruption or something. Anyway, let's just keep the momentum going here and start filling in these guys. So what do you want? What do you want? Primitive restart enable. No, that's going to be initialized to false by that thing. We just set topology, and we can call get primitive topology, and we just have everything here in the desk. So primitive topology. Maybe I'll just actually set that false just to be very clear. Okay, so that's like one state. I'm gonna add a few of these guys here, sort of separate this even more than otherwise would be. Okay, so tessellation stage, we don't really use tessellation yet, but we can. There's no reason not to do this. And it's called, yeah, it's the same thing we actually get. These guys are the same thing. Okay. So, rasterizer state. So, what do we have? Okay. All right. So call mode is get call mode. Desk. Call. No. What's it called? Oh, they're in like it's rasterizer and call mode. Yeah. That's call mode. Depth binds enable. I'll just copy it how I've done it for the other backends. So I do something like this. If that's larger than 0 or rasterizer sloped scale that is larger than 0, then we will have that enabled. That was enabled. Depth clamp enabled. Yeah, this is a tricky one because here we have depth clip enabled. I think this was the same thing on metal as well. I don't exactly remember. Oh, so if okay, just go. So if depth clip is enabled, then depth clamp is false, actually. Yeah, there was some like weird thing with this. It was kind of like backwards. Otherwise, it's true. I think that's how we're supposed to actually set that up. Right, front face is it's one of those guys, right? Right, but we want to check something here. I think this is a Boolean. So front counterclockwise. Yeah. So this would actually be counterclockwise. Yes. Good. What comes after front face? Next, that's not. I don't need to do anything with that. Get fill mode. Desk rasterizer fill mode. When I say I don't need to do anything with p next, I do need to set it to 0, but these initialization statements here will actually handle that for us. I'm going to set that to false. I don't think rasterizer discard enable. I don't know. I'll just keep it as false for now. It's probably the safest way. And I think there's no line width here. Is line width actually a thing in rasterizer state in Vulkan? I don't know, but we'll just set it to set it to 1 here because I know for a fact that the line width is not a thing in GFX API. So it's not. We're not going to have a value for it ready to go and ready to fill in. Okay, so multi-sample state. Well, we don't actually use multi-sampling at all, so we just need to initialize this to some nice off value. VK sample 1 bit, right? Not 16-bit, and 1 bit. Sample shading enable is VK false. min sample shading is 1. Alpha to coverage enable is VK false. And alpha to 1 enable is also VK false. Just set everything to the off position essentially. Okay, then we have the big ones. So depth stencil state and the color blend attachment state and color blend state overall. And these are the ones that are sort of, they're very verbose and they are easy to get wrong. But we still need to fill them in. So let's just do depth test. What should we do first? Back front, yeah. So I'm gonna do this in the same order I do here on the other metal one. So depth stencil, depth test enabled. Again, I don't know if we actually need to like do it like this. If we could actually just take that away and do it like that. I think we can, but oh, I don't know. And depth right enable. Desk dot depth stencil depth right enabled. And same thing. Yep. Depth compare up would be desk. No, it would be actually, we would be getting it from. We would be converting it in depth stencil depth function. Depth bounce test enable is just VK false, I think, for now. Stencil test enable is desk depth stencil test enabled, and this thing again, like so. That should be good. And then we have the front faces. So depth stencil state front fail up, get stencil up, desk depth stencil front face, stencil fail up. Oh, these are ridiculously tedious to do. Pass up, pass up, and then we have depth fail up, and then we have compare up. I'm reading this from the documentation here on the side, if you're wondering where I get them. That's not right. What is that? That's like a comparison function, I think. Right. So stencil fail up, and this would be pass up, and that would be depth fail up, and that would be stencil function. Okay. And then we have so this was the front face. We'll fill in these front ones. So we have the front read mask. Read mask. We have the desk depth stencil front face read mask, and that's a uint 8. Okay, so we'll just cast these guys to uint 32. Read mask, right mask, and reference. So this should be then right mask, and this should be, it's called ref, maybe? Yes, ref. Right, so that was the front face. And now we can just copy this guy and do the back face. So some column selection here, And that would be back. And then we have something like this, and we'll just replace all of these front faces with back face, and it should be good because we have the exact same thing. Right, so that was a depth one, except we have these two guys here, and what I don't even know what that is. So to like 0 to 1, doesn't that sound good? I don't exactly know. Maybe we don't even need to set these. Let's assume they have some sensible default value, but we'll see. Okay. One more sip of coffee. And yeah, this is super tedious to do all this, like converting things from one format to another. But that's the last one. It's probably the biggest one, but it's still the last one. And then we have all the states set up. So let's just keep going. Like, okay, color, blend state. We'll initialize that. And again, I have the members here on the side. Logic op enable would be vk false. I don't do anything with that. What do we set this guy to? And I don't know, copy. We're not using it anyway, so it doesn't matter. Alright. So attachment count is going to be desk, blend, render targets, size. And the pointer to the attachments is going to be this guy here, which we need to fill in next. I think that was essentially it, so we don't need that. We set that to some sensible things, and then we have those two, yeah. Yeah, that was all for that one, but we still have to actually, we'll put it on the next one. It's kind of its own thing. So we have size t, I is less than 8. And 8 because it's just 8 everywhere, and I used 8 here as well. And I use 8 on the other backends as well, and I think 8 is generally the maximum number of blend attachment you can have in most APIs, I think. Okay, so we have these guys then. Color blend attachment state. We need to fill in these guys, so we have like what do we call it? Like attachment, I guess. We'll do it like this, so we have like a writable thing here. And now we need to essentially figure out if this thing is going to be enabled or not. And we can do that by checking if the description blend render targets size is larger than I. And if it is, then it's like enabled. Otherwise, we just set this guy to some reasonable defaults once again. Like so. Color right mask. What do we have here? We have. Oh, we just have all kinds of things. We just have all kinds of things. But we'll set that at least to all the components, all the color components. So that would be R is the first one. R bit. It would be this. It's going to run off the screen if I do it like that. So do that one, or that one, or that one, or that one. And then these, of course, would be R, G, B, and A. And then the most important one is blend enable, VK, false. I don't know if this is actually used if we don't set the blend enable, but That should be a pretty safe one. Okay. What about the enabled one then? Then we have the render targets, and we have to get it out of this guy. That would be a const thing because it's part of the description, which we're not allowed to actually poke at. Render target blend description RT is that, right? Okay, so let's do the most important one first. Blend enable is, and it's not necessarily enabled. Actually, so this is not true. Let's take that away. It's not actually enabled. It's just that we have actually a target here. So it's vk true, else vk false, like so. Then source color blend factor. I typically do this in a very specific way. So we do the source color blend, and this would be rt.source blend. And then we have destination blend. We get a blend for that as well, and that's rc dist blend. And then we have the color blend up, and that's a get blend up. RT blend up. And then we have the same things for the alphas. So attachment dot source alpha blend factor. That's again get blend RT source blend alpha and dist alpha blend factor get blend RT dist blend alpha. And we have alpha blend up. That's get blend up and RT dot blend up alpha. Okay, have we used any value twice here? We should not have done that. If I have done it, then that means I've made a mistake. Like you can highlight things here, and click it, and it highlights the thing. Can't talk anymore. It highlights the other occurrences of that. So we need to set in the mask, and this is specified a bit differently in our in Vulkan or in VEZ than it is in the render target. This is essentially just not copy pasting, but just doing exactly the same thing I do in Metal. So color right mask, and we add VK, and we have these guys, right? These things here, right? So that would be 1, 2, 3. And we have G, B, and A. Okay. Okay. Is that it? I think that's it. I think that is it, my friends. And we should make sure that, okay, we've written those, Min-depth bounds, max time, we just set them to, oh, blend constants. We haven't set the blend constants yet. No. Okay. And they can be found in I think, is it desk.blend factors RGB? Yeah. Called blend constants in Vulkan terminology. So if we actually have any attachments, then we do something, right? Otherwise, we just set them all to 0. So let's do like a uint32 in I 0, I is smaller than 4, and we increment I, and we set mblend, oh, come on, blend constants I to 0, and if not, then we set it to desc.blend vectors RGBA, and just copy the thing over, and that's like a float, and that's also a float, so we could have mem copied it, but who gives? All right. Phew, I think this is now us collecting the state together. So now binding it should be actually significantly easier. And let's again have a look at color blend state, attachment count. Is this actually correct? Is this actually correct? Yeah, because like the render target will have yeah, I'm not sure. Let's see what happens. I guess the validation layers will once again come to our aid if we do something stupid. So VEC command set vertex input format. So we'll start with this one. No, actually we'll not. Vertex input format is not that. It's the thing that we have in our shader program. So shader program and get vertex format. No. Nope, that's not it. That's not it. It's just called vertex in. Yeah, I took the setter, the getter away and just made everything public, so I can just access it like that. Yes. Okay, and now we will be actually. Now we will want to do this. So let's copy this guy, and it should be like VEZ command set input assembly state. Oh, come on, why do you make it difficult? And no, it wants a pointer, so that. All right, and then we have, let's just actually, 1, 2, 3, 4, 5, 6. Is that the case? I think it is. We can just set all of these states, and it will of course complain that calling it with the wrong function, but it is what it is. All this states, so this should be set tessellation state. It's overwriting my things. Don't do that. Rasterizer state. Is it? No, it's rasterization state. Yeah. Let's see if we can. Just, that would be like the M becomes a set, and it's otherwise it's the same name. So there we go. We have those set. And then we have this other list which I copied here. We have the depth bias, so command set depth, no, depth bias, there we go. And it's these three guys. I'm not even gonna set the line width right now. It's silly. I'm just gonna skip it. We don't really use it. It will be whatever VEC actually. Whatever VEC actually wants it to be. So if we have this color blend state attachment count larger than 0, then we should set these guys next, and that would be VEZ command set blend constants. Yes, that is indeed a vector, so let's put that. Okay. Depth bounds. Right, so it's these two guys. I don't actually know. But let's set these values and then command set depth bounds. So min depth bounds and max depth bounds, right? Min depth bounds, max depth bounds, right? Something like that. Let's see if it gets disappointed with us because we've said something stupid. And then I think that the last thing we'll need to do is set the stencil. If that we only need to set if the stencil state is actually stencil test enable. Yeah. Is there not like a stencil right enable? Depth test enable, depth right. It's just one value. Okay. Well, alright. Well, I guess we'll set all of these 6 if this one is true. So VEZ command set stencil compare mask. Yeah, that one. That's the one. And the face is now the front face. So that was like BK stencil face front bit. And then we have this one. No, it was compare. Yeah, alright, yeah. They call it compare. I call it read. Okay. So burp. Compare, and then this was right. And that would be right mask. And this was the reference. And it's this guy. And then stencil back right mask, back reference, and back and back. Okay, so now we've set all the things that I would actually not want to set here. this was the thing with the all the splitting and merging of all those boxes that I drew. Actually, the only thing I would like to set here is this VEC command bind pipeline. Yes, that is what it is, and of course we do have that. It's called VEC pipeline, and it's the thing we created as the first thing here. The thing we fed all the shader stages to. Whew, does that actually return something? No, it's a void function. Okay, so in my ideal world, all of this state here, all of this onto that point would have been kind of baked into this guy, and then binding would be just setting the pipeline here. Yeah, that is maybe not exactly, but that's almost how native Vulkan works. And we made a mistake. What have we made? It's not an assert D, it's an assert F. Just like a print F. Okay. Yeah. This was sort of a laborious thingy. We don't actually need to do anything in Create currently. I mean, I could perhaps move this thing there, but why bother? The creation of these are anyway, they're like init is called, then create is called, and then destroy is called. So we don't really need to do anything in create. We still need to have it though. It is technically when the first reference is is actually added, and this is when the last reference is taken away. But we still need the description, and we have it handily here in the init function. So let's just do that. Let's keep it like this. And we can perhaps just make sure that we can actually run through each of these things once. We should be binding things already. Nothing gets drawn because the render context obviously isn't done yet. That's the last thing we actually have here. We haven't done. Success, that's good. This should not really fail. This is just setting values. This is just setting values. Apparently we have some blending going on, that's cool. Yeah, it goes to, let's jump to this guy, run the cursor. That's good, that's good. Okay, so we got there. We'll probably get to some other ones as well. Let's see, we should probably get to like a binding one as well, don't we? Oh, but we don't. Of course we don't. Yeah, we don't get here. We get to render context VK, and we get to here. That's where we get. But we don't actually call the bind function. So yeah, we don't get there, but we'll do that in the next part. So, right, the next part may or may not be the one where we get things onto the screen. I mean, in the best case scenario, the next part will be the last one, and we'll fill in this guy, and everything will just magically work, and we'll get a beautifully rendered scene using Vulkan. But that is kind of unrealistic to expect, even though everything has kind of gone pretty well. So maybe there'll be like a couple parts more. We'll see how much actual troubleshooting we'll have to do. However, next time we might get something onto the screen, so that should be an exciting one. If you're with me this far, then I thank you for your time. Click all the buttons, like all the videos, bash all the things, and I will see you in the next one. Bye.